So we are starting topic 4, and today we're going to be focusing on 4.1, which is reciprocal functions. So the first thing we need to do is just find out what a reciprocal function is. So a reciprocal function looks like this. Y equals, or f of x, whichever you prefer, 1 over x. So that's our reciprocal function. And what we're going to do with this is we're going to plug in some numbers. So we're going to take this x value right here, all of these x values in that table, and we're going to plug them into our function. So we're going to start by doing 1 over negative 2. So again, I just took this negative 2 here and I plugged it into my function there, okay? So 1 over negative 2 is just negative 1/2. It's the same thing. And then 1 over negative 1, well, that would just be negative 1. 1 over negative 1/2. You can put that in your calculator if you need to, but 1 over negative 1/2 would become negative 2. Plugging in 0, we would have 1 over 0. If you try that in your calculator, it'll say error or undefined, and that is because there is no way to divide by 0. So this is undefined. Okay, and then the rest are very similar to what we just did. It just doesn't have that negative. So 1 divided by 1/2 would become 2, and then 1, and then 1/2. So we have all these points now, right? Because our coordinate points are x, comma, y. And so we're going to plug it in. So, or not plug it in, plot them. So we have negative 2, and then we go down negative 1/2. So we have a point there. And then we would do the negative 1, negative 1. So negative 1 right here. Negative 1/2, negative 2 would be right here. 0 is undefined, so there's no point there. We'll come back to that. 1/2, 2, so right here. 1, 1, right here. And then 2, 1/2 would be right here. And what that 0 undefined looks like is a asymptote. And that is saying that there is a line right here. And again, we did that because we can't divide by 0. Okay, so we just talked about an asymptote right here. We're going to write that definition. So an asymptote is a line on the graph that, I'm going to rewrite that. I'm going to change the wording a little bit. A line that the graph approaches but never touches. Approaches but never touches. Okay, so this line on the graph, it's gonna go closer and closer, but it's never going to touch it. Okay, and then we're gonna just draw our shape as best as we can. And then it's going to go like this. So this is what our parent function would look like. So we actually have another asymptote on here that we didn't see when we were looking at the table, but if we think about it, if we have any number we plug in for x right here, it's just going to get smaller and smaller, but it's never going to actually equal 0. So we actually have a horizontal and a vertical asymptote on this graph. So this would be the horizontal asymptote, and then this is the vertical asymptote. Again, because vertical is up and down, so we had a vertical asymptote. So vertical asymptote at x equals 0. And then we had a horizontal one at y equals 0. So we actually had 2. And for the rest of the notes, you'll see VA for vertical asymptote and HA for horizontal, just to save some time in the writing process. So again, vertical is your up and down, and horizontal is your left and right. So what is the domain and range of this function? Well, the domain, we said it can be any of these numbers except for 0. So we're going to write it as x is an element of all real numbers, and then we said that x cannot equal 0. So it's any other number except for 0. And then we said it's the same for the y. The y was all real numbers. We just can't make this function equal 0. So y cannot equal 0. Okay, so that's the parent function for reciprocal functions. So what you see on this screen right now is what is always going to be the case for this function right here. Okay, this is the parent function. Now, we can do some translations to it, which we will be talking about in just a minute, and then it'll change. But anytime you have this exact function right here, the parent function of reciprocal functions, it's going to have a horizontal and a vertical asymptote at x equals 0 and y equals 0. Okay? So let's go ahead and take a look at those translations that I just mentioned. So I'm going to rewrite our parent function, but I'm going to rewrite it with the translations in it. So we're looking at just translations. We're not looking at dilations or reflections or anything like that. We're just looking at some translations, which, remember from our previous chapters, is the shifting left, right, up, or down. So the h value, just like before, is going to be our horizontal translation. And one way to kind of remember is h stands for horizontal. So it's going to be moving it left or right. And one thing to really remember is that it's opposite of what we see. Okay, and then the other one we have is our K, which is our vertical translation. And so that's going to be moving it up or down. And this one is exactly how we see it. So if it says +2, we're going to move up 2. Okay, so those are the translations, and it's very similar to the quadratics that we did or the absolute value. It's just a different parent function now. So let's look at an example. We have example 1, let y equals 1 over x minus 3 plus 2. So our h is right here, and our k is right here. And it says, describe the translations from the parent function. So we have a minus 3. Remember, it's opposite. Remember, opposite. So it says minus 3, so I'm actually going to the right 3. So even though on a number line, -3 would be to the left, it's right 3. And then it says +2, and we said that's the same. It doesn't, no opposite, so it's up 2. So I'm literally taking this entire graph up here that we just looked at, and we're moving everything up to right 3. So I'm going to draw my up 2. So I'm going to take this horizontal asymptote right here, and I'm going to move it up 2. So now it's right here. Then I'm going to take the vertical asymptote that was on this graph right here, and I'm going to move it right 3. So right 3. And then all those points that we had before move with it. So we can kind of see the pattern here where it went over 1, up 1. And so it's just going to do that again. Over 1, up 1. And then this one went over 1 and down 1/2. And the other one went over 1/2 and up 1. It's the same shape. It just moved. Again, all the points moved right 3 and up 2. So from here, we moved it right 3, 1, 2, 3, and then up 2. And then the pattern is the same again on the other side. most of your graphing for this unit for our class will be on Desmos, so the important thing is to be able to identify the translations. So domain, x is all real numbers except x cannot equal 3. That's where our vertical asymptote is. And then range, y is an element of all real numbers. Y does not equal the 2. And then for our asymptotes, we have a vertical asymptote at x equals 3 and our horizontal asymptote at y equals 2. I forgot to mention up here, one nice thing about asymptotes is that the vertical asymptote will always be at x equals h, and the horizontal will always be at y equals k. So it's kind of nice that we can just take our h value from this equation or any equation we have and just find the h and k value and know where the asymptotes are. Okay, so the best thing I would say for next is to try that second one on your own. Again, the graphing is not super important as we're going to be using Desmos for a lot of it, but at least being able to do these by yourself. Okay, so pause the video and try and then check your answers. Okay, so we have that it goes +2, which means it goes left 2. And then we have a -1, so that's down 1. So again, we have down 1, which would be our horizontal asymptote. So we have a horizontal asymptote at x equals -1. And then we have a vertical asymptote at y equals, or whoops, I did that backwards. This is x equals -2, and then this one was y equals -1. Okay, and then our domain is going to be all real numbers except x cannot equal -2. And then our range is going to be all real numbers, y just can't equal -1. And for the graph, I'm just going to draw it in. I know that it goes over 1, up 1, and then a half and 1. And then just draw as best as I can. And again, I'm just remembering the pattern of the parent function. And that's it for 4.1. Feel free to rewind or watch anything over again or put any comments or questions, and I will get back to you. Thanks.